Hello, Algebra 3 class. This is my third recording. This is kind of funny, but my first file got corrupted and wasn't uploading to YouTube. And then my second one, I recorded the whole thing. You could see writing, but I did not have my mic connected into my system here, so there was no sound coming through the video. So third time's the charm, and here we go. We are looking at section 1.6, and what we're going to be doing is dealing with numbers that use scientific notation. And the whole thing that we're going to be doing with scientific notation is converting decimal to scientific notation and then back from scientific notation to decimal. And then we'll have a couple other examples where we multiply two numbers that are expressed in scientific notation or divide those two expressions also. So let's just go ahead and get started. Right, a number written in scientific notation is written as a number greater than or equal to 1 and less than 10. So it's between 1 and 10, or equal to 1 or 10. Well, yeah. And then that number is multiplied by a power of 10. So that's why you hear some number times 10 to a certain power. And that's what is expressed down here. These examples are written in scientific notation, because you can see that this right here, 1.5, is something between 1 and 10, and then it's multiplied by a power of 10. Same thing goes with part B right here. That is also a number between 1 and 10, and then multiplied by a power of 10. Alright, so let's look at steps to converting numbers in scientific notation. Alright, to convert a number to scientific notation that's in decimal form, let's look at this case here. First, what we're going to do is move the decimal point, depending on if it's something greater than 10 or something less than 1 is how you're going to move the decimal point, okay? But here in this case we have something greater than 10. So we move the decimal point to the to the left so many units. And whenever we're converting to scientific notation and we move that decimal point to the left so many units, this is what happens. We end up multiplying that decimal number by a power of 10 that has a power that is positive rather than negative. And you'll see a couple examples that I have prepared for you here in just a little bit on which way to move the numbers and their powers that are either positive or negative that go along with it. Okay, so let's do another step process here. Alright, so here are the steps on converting from scientific notation to decimal form. It says, first observe the exponent of the power of 10. And this exponent is what's going to tell you if it's positive, you're going to move it over to the you're going to move that decimal point to the right so many places. And if that exponent is negative, well, you're going to move that decimal point to the left so many decimal places. And that is just simply converting scientific notation to decimal form. That's how it's done. So let's look at a couple examples. This is asking us to express in scientific notation. So let's just get down to it. This is how I'm going to show you how to do it, okay? The decimal point in a number like this is always at the end. And we're going to move that decimal point over so many units. I just counted 4 units there, or sorry, not units, decimal places. So our number now is 7 7.93. And then we're going to multiply it by a power of 10. So times 10. And then the power that we put on 10 is how many decimal places we just moved that decimal point over. Let's see. So 4. So 7.93 times 10 to the 4th. That's our answer. And this other one, it's a number much less than 1. So what we do is we are going to move that decimal point over to the right now. And we move it when we're converting to scientific notation. What happens when we're moving it to the right is this exponent will be negative rather than positive. So let's move this one over 1, 2, 3, 4, 5 decimal places. So 8.5 times 10 to the negative 5th is what happens. So that right there is writing both of these numbers in scientific notation. Now let's go the other direction. Let's convert from scientific notation to decimal. So this is how it's going to be asking you to convert from scientific notation to decimal in your exercises. It will ask you to express each value without exponents. That's the same thing. It just simply means convert this to decimal form. Okay? So very similarly how we did this in the previous slide, we're going to count decimal places according to the exponents that we have here and move it in the proper direction according to that exponent too. Okay, so for this one, we have 5.3 and we want to move it 6 decimal points to the right. Okay, because it needs to be a big number. 5.3 times 10 to the 6, that's going to be a big number. When we get it down here, you'll see that that is going to be a small number. Alright, so let's move this to the 6 decimal places. So 1, 2, 3, 4, 5, 6. There's our decimal place. Fill in with zeros. So we got 5 trailing zeros. This is going to be 5,300,000. That is in decimal form and without exponents. Alright, part B here is the same thing, except, like I said, it's a negative exponent. So we're going to be moving that decimal point over to the left this time. I'm going to start my number out over here, because now we're going to go the other direction. So over 4 decimal places, 1, 2, 3, 4. There goes my decimal. Fill in with zeros. Rewrite the number. So 0.000214. That is our solution to this. Okay, so let's do a couple more examples. Again, it says express in scientific notation. For part A here, just multiply these numbers together, and then we're going to convert that number to scientific notation. So when I multiply these two numbers, sorry, you're probably hearing my littlest one in the background screaming. Oh well. So here we go. That's these two numbers multiplied together. And now we're going to change this decimal to scientific notation. And so move this decimal over 1, 2, 3, 4, 5 places. And now change it to 1.5 times 10 to the negative 5. Because remember, small numbers get negative values, big numbers get positive values. All right, part B here, one way you can do this is just by plugging all of this into your calculator. But this is kind of how I want you to show your work whenever you are asked to do this in class, okay? One way you can multiply these two expressions that are in scientific notation is by multiplying the decimal numbers together, so the 4.78 and the 1.96, multiply those together, and then multiply the powers of 10 together. Okay? Because whenever we multiply these powers of 10 right here, they have both bases are the same. They're 10. And you just learned in the last section on exponents, that if you have the same bases, what we can do with these exponents is add them together. So that's what I'm going to do. This is going to be 10 to the 14th power. And now in your calculator, put together the 4.78 and the 1.96 by multiplying them. And this is what you should get, 9.3688. And just write it out properly like you did up here in scientific notation. 9.3688 times 10 to the 14th. And we are done. Alright, I have one more little example on the next slide. Okay, just like we had multiplication of two expressions, two numbers that are expressed in scientific notation, here we have two numbers that are being divided. We're kind of going to do this in a similar way that we did the multiplication. We're going to put together the two decimal numbers, just like this, 1.5 over 4.5, and then put together the powers of 10. So 10 to the 35th over 10 to the negative 26. Okay. Now we can go ahead and divide the 1.5 and the 4.5, and what you're going to get is a 0.33 repeating. And then here we're going to get, remember, since we have 10 as our base in both of these, use your exponent rules to put together our exponents. So it's going to end up being 35 minus negative 26. So basically adding 35 and 26 together. And what we get is a 59. Now on this one, it's going to change just a little bit than what we did with the last number. The last number we just ended up saying, okay, 0.3 repeating times 10 to the 59th. Well, that is not in true scientific notation because this number right here is not between 1 and 10. We need to express that between 1 and 10. So to do that, move it over one decimal place, and that's going to change this by one decimal place also. Okay, so 3.3 repeating times 10 to the 60th power. Now that is in the correct, it is expressed correctly in scientific notation. And that right there is the last example I have for you. So I'll see you the next time we meet. Bye, everybody.